Hey guys, this is Invisible, and I'm delivering that video explaining the passive crafting automation for Universal 2.0, and it is these subnet thingies that have been in the background of screenshots and such. It kind of looks complicated, I guess, but really the way it works is quite simple and very powerful. They don't break on server restarts, and unlike active crafting, and honestly, in some ways, they're more powerful than active crafting because it allows you to parallelize these processes very easily, and also to use your existing infrastructure in a, I guess, to share these processes. So that way you don't need to build extra dedicated infrastructure for any one process or any one line or anything like that. You can just pass it universally. You can save on TPS, you can save on effort, it just allows you to build a more efficient base. So here's exactly what's going on. The first thing I should start with is, actually let me go over here, it's a better view of what's happening. The first thing I should start with is this. This is a super chest, and it has an item detector cover on it with the thing you want to maintain and the amount of that thing you want to maintain, and it's outputting a signal to this toggle bus. This toggle bus is connected to this I/O port, and this I/O port feeds via machine holding conveyors into this I/O port. It's effectively a cell shuffler that picks up items from inside of this interface whenever this toggle bus is on and the passive crafting loader is ready to craft the thing that you need to maintain. Now, what exactly is stored in this interface is a partitioned restricted cell. It's partitioned for molten arcanite and 589 kiloliters of it, which is exactly enough to do something like 32,000 screws at once or something like that. So you want to have a partition restricted cell to hold the thing that you want to do a recipe with and an exact amount of that thing to batch your recipe properly. If I didn't use an exact amount of the thing that I want to craft with, then bad things will happen. You'll see in a moment. So that I/O port is connected to that interface with a storage bus, like how the active crafting loader, for example, would normally. I should probably turn on night vision. Like how the active crafting loader would normally pick up, say, non-consumables with this miniature subnet right here and the interface with the non-consumables locked in it. Okay, so now when this item cell is picks up a cell with a thing that you, or partitioned and restricted to hold a certain amount of the thing you want to craft with, it pushes it into this I/O port, which is transferred to cell and transferred to data network. And this I/O port is connected to this cyan subnet. The cyan subnet is used to distribute the cells that are partitioned and holding the recipe inputs to specific I/O ports. There's only one here because there's one input, recipe input for arcanite screws. It's just some arcanite with a screw mold. But down here, there, for example, at the which one would be easiest to see? Okay, for example, at the Ender Quantum Component passive loader, there are 3 inputs for the Prass recipe. If I were to grab this, you can see there are 3 inputs. And as such, you need 3 separate cells to hold the recipe inputs and certain amounts of the recipe input to do a thing. And once they're jettisoned into this cyan subnet, they are distributed via filtered insert-only storage buses to their respective I/O ports. Just like up here, you can see it's filtered to the same cell that's holding 580 89 kiloliters of Arcanite. And once the empty cell goes inside of this IO port, it's used to pull the thing that you want to craft with from your mainnet with a filtered extract only storage bus. In this case, it's Arcanite, so it's only pulling Arcanite off of mainnet, right? And then once the cell starts and finishes, once the IO port starts and finishes pulling the crafting input onto the cell is moved to the output when it's filled. Well, how can the IO port tell that the cell is filled? The IO port respects cell restrictions. So if you were to restrict the cell to hold a certain amount of a thing, the IO port, once the cell once the cell reaches the threshold for its restriction, the IO port and the cell itself is considered full. So it'll actually move to the output of this IO port. I shall demonstrate. If I disconnect this and take all of that out, and then take this cell, if I put the cell in here, went to the output with its 589 kiloliters of molten Arcanite. Okay, so that's that part of it. And so this IO port, it's on a miniature subnet with a filtered storage bus with the thing that you want to pick up, and the IO port itself is set to move to output when the cell is full or the network is filled. Now, there is another miniature subnet with another IO port. This IO port is connected to a storage bus, and said storage bus is facing the IO port that has the cell with the items contained within it, or well, in this case, fluids. The purpose of this is to have this item cell pick up the fluid cell with the fluid contained in it and have it sent to your crafting automation. Just like the active crafting loader, the cell is, once it picks up some Arcanite inside of the partition cell, it picks up non-consumables. So in this case, it's going to be a screw mold and a program circuit, which you need for the UPAs. But in most cases, if you're using normal machines like Fluid Solidifier, like the Fluid Shaper, you're going to only have a screw mold in here. And then it goes down to get picked up by your machine automation. And that's pretty much it. There are a few things to note. The reason why this works specifically for fluids is because you can store fluids with... I can demonstrate this actually. You can store... wait, let me let's grab this and then this and... Okay. You can store fluid cells with fluids on them on item cells, as you can see. And so the purpose of that is to have this item cell take the fluid contained within the fluid cell to your machine automation, so that way it can do a recipe with it, with the fluid, and also with the non-consumable in it, because you can't package a non-consumable and a fluid normally. You can't put items on a fluid cell, and you can't put fluids normally, just raw fluids, onto an item cell. So you have to use this trick in order to use fluids in your passive crafting loader recipes. That should go right here, actually. Okay, so that is the fluid specific setup. Now for items, the concept is the same, except there is one extra step. Instead of placing the storage bus on the network for the recipe carrier to pick up its items and item cells or fluids, you need to take the item out of the I/O port that's used to pick up. You need to take the item cell out of the I/O port that's used to pick up the item that it has to pick up from mainnet, and put it on, and put it and its contents onto another network. So this way, once, say, Ender quantum components need to be crafted, a recipe carrier cell can pick up both the contents of the item carrier cell and the item carrier cell itself. Now, well, you may think, why do this for items? It's not necessary. The recipe carrier cell already picks up the item input from this ME chest here. Well, that's because you want to control the amount of items that are pulled into this subnet, so that way you don't buffer too many items. That's why the item carrier cells, the ones that are partitioned and restricted, are stocked in this interface, and it's why this cell shuffler is toggle bus depending on the item threshold that you set in the item detector cover, because you don't want to buffer too many items inside of the subnet, or else it could screw up the batch size that you're trying to craft with. I ran into that problem before, and that's how I came up with this part of the design. Another thing to note is you have to pick up each. You may notice that you have to pick up each of these item inputs for, in this case, Ender quantum components separately. And the reason for that is, if you run out of any of these item inputs on your mainnet, for example, the recipe will not continue, the recipe carrier cells, rather, will not continue to pick up inputs to try to craft this thing without actually being able to craft it, because you ran out of items. Because you see, since the retrieval of the item inputs and the item input cells are separated by each one of these subnets, they are separated and isolated, it won't actually do anything until something appears inside of this I/O port. But you see, something can only appear inside of this I/O port when the restricted cell gets filled with the proper amount of items to do one batch, or whatever you define as a batch, for the given recipe. And that is another thing to note about that mechanic in particular is, storage buses, when they're connected to I/O ports, can't actually see what's inside of I/O ports until they go to the output, which means, in other words, until the I/O port has finished its work. That's how this works for the I/O ports to fill the item carriers with items. Actually, they only will go to the output once the item carrier cells are filled, and then and only then will the cells be moved up to the I/O port to this I/O port to dump their contents into this chest and have the recipe carrier pick up the cells. If that wasn't entirely obvious, I just thought it would be nice to mention, because that mechanic and I/O ports recognizing that restricted cells are full when they reach the threshold of items that they have been set to are notable things to mention about why this passive crafting loader works. So as a demonstration, we have some glowstone blocks here. It's a fluid recipe, which means the recipe carrier cells, the storage bus on the I/O port, and we have some cells that go in here. I could get to the storage bus. We have some partitioned and restricted cells with molten glowstone and 5.76 megaliters, which makes like, I think, 16k glowstone blocks at once or something like that. And that goes inside of this I/O port and will go to the output, allowing these item cells to recipe carrier cells. I've just been calling them that, to pick up the item carrier cell. Now if I change this item detector cover value to 3 million, the toggle bus will turn on, inverted toggle bus by the way, and the cell shuffler will start cycling in cells. Oh, there they go. They're flashing briefly. And as you can see, glowstone blocks is going up in value. And it will stop eventually once it hits 3 million in a minute here. But in the meantime, there is another thing that I forgot to mention about this. The reason why I'm using storage buses connected directly to I/O ports so that those storage buses can only see the output of the I/O ports is so these cells here can stall in the input of the I/O port. They do that because this network is technically empty, since the only thing that it can see is the output of the I/O port here that the storage bus is facing. And they do that because that's just how this mode works. That's the change that Samsung made originally to allow the UA2 active crafting and now passive crafting loaders to work, and that's also why it requires nightly. This would be a very large pain to keep the cells dormant in the input of the I/O port until something appears inside of the network, in this case in the output of this I/O port, where when the recipe is ready to be, when a passive crafting or even active crafting recipe is ready to be crafted. So it would be a pain to make these stay in the inputs. So that's why unstable, that is. So that's why nightly is required at large for Universal currently. Anyway, we hit 3 million glowstone, and since the item detector cover popped, it turned off this inverted toggle bus, and now the cell shuffler cannot see the interface that has the partitioned and restricted cell of molten glowstone stocked anymore. Now, there are a couple more things to note after explaining what exactly is going on with the cell shuffler and item delivery. Those cells are actually in the NC network that we have for the entire Universal operation. They are right here. The reason for that is because obviously if you have cells that are going into machines, getting loaded and then unloaded, once the recipes are done in said machines, they get unloaded here like normal active crafting recipes would do. And as such, these I/O ports send the contents left within the cell, which would be the non-consumables, and the cells back to the NC, which is why the cells are in here, and you have to stock them in an interface from, ideally, your non-consumable network. Although you could separate the networks, but it's not really entirely necessary for you to do that. And one last thing that needs to be mentioned here is the reason that you want to use a cell shuffler like this is because you don't want to insert all of the item carrier recipe or item carrier cells into the passive crafting loader, because the quantity of these cells are actually controlling the amount of parallels you have going at once for a passive crafting recipe, sort of like how it would be with non-consumables. If you ran out of non-consumables on an active crafting recipe, then you would simply run out of available parallels to do for said recipe. So if you want to parallelize your passive crafting processes, you have to do a cell shuffler like this, because this is just the only way that I came up with to have one and only one set of item carrier cells enter the passive crafting loader at once. You can see that it doesn't necessarily have to be one cell either. It has to include all of the cells for, say, stellite dust. It has to include all of the item carrier cells that are required to do a single batch of the recipe. And again, if you want to parallelize said recipe to do multiple batches simultaneously, you'd have to add more sets of these cells to your NC network. And I think that's it. Actually, that is the passive crafting loader. Pretty simple, and it is, again, it's quite powerful because if it wasn't apparent already, there are quite a few loaders here. There are, what, like over 20, I guess? Some for the UPAs up down here and up here, and some even running on presses, and we're having no issues with throughput or with auto crafting capabilities. Hell, I forget that these are pure most of the time, because they're working just as well as if we had dedicated machines to do all of this. These amounts of items are what we stock normally, and they aren't usually down unless we're out of a material. But when we aren't out of material, these are pretty much always stocked, which is the most interesting part about this. So yeah, that's about it.